All right, so this is the Unit 1A assessment review. It's going to be the test review for the test that's coming up. The first thing that we're going to look at is the topics, okay? So let's remember that the first thing we did was we looked at the number system, okay? We looked at rationals, irrationals, whole numbers, natural numbers, okay? Remember those were the same thing, okay? So that's what I'm going to start off with first. Then the next thing I'm going to do is I'm going to go over converting decimals to fractions, and then repeating decimals to fractions. And then after that, we'll look at approximating square roots, and not only approximating square roots, but numbers in general. And then we'll look at using the laws of exponents and how we apply them. And then after we after we review the laws of exponents, we'll look at finding solutions of square roots and cube roots. And then finally, the last thing we'll do is we'll look at scientific and standard notation. Okay, so remember the whole numbers were the natural numbers. The whole numbers and natural numbers are the same thing. 0, 1, 2, 3, 4, 5, 6, 7. Okay, it's just those basic numbers. That's what we call the whole numbers or the natural numbers. Then we have the integers, which are going to be 0, 1, -1, 2, -2, 3, -3, 4, -4. Okay, so it's just the whole numbers with their negatives. Okay, so 1, -1, 2, -2. Okay, and so on. And then we have the rationals, okay, that take the form x over y. So a fraction, okay, but it doesn't have to necessarily look like a fraction, all right? So x over y, where x and y are integers. And remember, we don't let y be 0 because we cannot have division by 0, okay? And then we looked at the irrationals, right? So we had pi, e, square root of 2, square root of 3, square root of 5, square root of 7, okay? And in general, we said that the square root of any prime number was irrational, okay? And then we also looked at this picture here, okay? So pretty much this small one right here is the whole numbers, okay? And then we have that the whole numbers live inside the integers, okay? As we see up here, 0, 1, 2, 3, 4, 5, 6, 7. Okay, those numbers are also found in the integers. Okay, so the whole numbers live inside the integers, and similarly, the integers live inside the rationals, because the integers are what we put on top and on the bottom of the fraction for rationals, the x and the y. Okay, so the integers live inside the rationals. Okay, and then you have the irrationals by themselves. Okay, over here, whole numbers are not irrational, integers are not irrational, and obviously rationals are not irrational. Okay, so that's why we have the irrationals have their own little set over here, okay? And how we can define the real numbers is just saying the rationals, so this entire blob plus this entire blob, the rational numbers plus the irrational numbers are going to be the real numbers, okay? So now let's look at some examples of rationals. All right, so let's say the first, let's look at this first example, okay? Just 7 over 3, all right? Why is 7 over 3 a rational number? Because it's integer over integer, okay? It's a fraction. It's one integer over the other integer, so it's rational, okay? Another rational number could be like -8 over 9, right? Because -8 is an integer, and 9 is an integer, right? For the same reason this one was rational. This one is also rational, okay? Because it's integer over integer, all right? And same thing, we can have -25 divided by -7, okay? This one is also rational because it's integer over integer, okay? As long as it's integer over integer, or it can be written as integer over integer, the number is rational, okay? And just 4 by itself is a rational number because it's just a whole number. And we know that the whole numbers are rational, right? On the little map, we saw that the whole numbers live inside the integers, which live inside the rationals. So that means that the whole numbers, the integers, are the entire set is rational, okay? And then we can, not only can we look at, does it have to look like a fraction, So for example, right here we have the square root of 36. But the square root of 36 is rational because that's what this B/C stands for, because the square root of 36 is 6, and 6 is an integer. And integers live in the rationals. So that means that square root of 36 is rational. Okay? And same thing, we could also have something like the square root of 16 divided by the square root, just divided by 2. Because the square root of 16 divided by 2, well, the square root of 16 is 4. So square root of 16 divided by 2 is the same thing as 4 divided by 2, which is just 2. And 2 is an integer, so it's rational. And finally, we can look at this last example here. This last example says the square root of 16 divided by the square root of 25. Well, yes, this is a rational number, okay? So notice it doesn't look like integer over integer at first, but when you dive into the actual square root value, you see that the square root of 16 is 4, and the square root of 25 is 5. So now we have 4 over 5, and 4 and 5 are both integers. So that means this number is rational, which means that the square root of 16 over square root of 25 is rational. Okay? And then we can look at some irrational numbers, right? We saw pi. That was the most famous. It's approximately equal to 3.14159. All right, goes on forever, doesn't stop. Irrational numbers never stop, and they never have a pattern. So maybe we should add that. Irrational numbers never stop and never have a pattern. Okay, so repeating decimals, when we go and look at those repeating decimals, those are going to be rational numbers. Okay. So back to this. So E is approximately 2.71828. All right, which is another irrational. Should have had some dots going here. Okay. E is another famous irrational number that you need to know about. The square root of 2, the square root of 3, the square root of 7. Okay, the square root of 11, just like we saw before. All right, the square root of any prime number is irrational. Okay. But remember, we looked at numbers like the square root of 8. Is the square root of 8, is it irrational? Or is it rational? Which one? So, remember what we did was I introduced this nice little square root rule where we said that if we know that the square root of x times y, so just the product, something times something else, the square root of x times y, that's going to be equal to the square root of x by itself times the square root of y by itself. Okay, we say that the square root of the product is the product of the square roots. Okay, and if we look a little closer into 8, then we see that we can rewrite the square root of 8 as the square root of 4 times 2. Since 8 equals 4 times 2, we can just sub them out for each other. And if you do that, then you see that the square root of 8 is equal to the square root of 4 times 2, because 4 times 2 is 8. Okay, you can just sub them out. Okay, you can do that in math. And then you get that the square root of 4 times 2 is equal to the square root of 4 times the square root of 2. But the square root of 4 we know is 2, so you just get 2 times the square root of 2. Okay, but since the square root of 2 is irrational, right? It's the square root of a prime number. Okay, so that means it's irrational. Okay, since the square root of 2 is irrational, then so is 2 times the square root of 2. Okay, if you could think about that a little more, the square root of 2, it doesn't stop; it keeps going forever. So if you take a number that goes on forever and you multiply it by 2, then you're just going to end up with twice a number that goes on forever and doesn't stop. Okay, so you're just going to have another irrational. Okay, and so we say therefore the square root of 8 is not rational. Okay, the square root of 8 is irrational. All right, because of this fact, because we can simplify it to get to twice square root of 2. Okay, and that's we're gonna stop there for the number system. That should be a pretty good review. If you guys have any other questions, feel free to ask, or you can just review your notes. You've got lots of good examples in there. Okay, so I'll see you guys in the next video.